Hi, I'm Shahul. I'm the co-founder of Exploding Radiance, and I take my coffee black and without sugar.
Hello and welcome everyone to another edition of the MLOps.community podcast. I am your host, Shahul Es, and today we are talking to none other than Shahul Es. This man has been doing very big things in the evaluation space. He's also been absolutely killing it with the Open Assist project. You may know him because he created the Ragas Project, which is an open source evaluation framework for RAGs or retrieval augmented generations. He's got such a pulse on the open source LLM ecosystem. We had a deep dive on how to look at evaluation, where to even start if you're thinking about, I'm trying to debug this. I don't know what is wrong. Is it the open source model that I'm looking at? Is it the prompts that I'm looking at? Is it that I'm serving it on the wrong type of hardware? Or do I need to check out my vector database? Do I need to look into that? Am I chunking it correctly? Sparse, dense vectors? I'm just throwing out buzzwords right now. But he got into it because he actually knows what he's talking about. And then we did a whole nother deep dive on the state of benchmarks. Shahul Es gives us all kinds of insights and wisdom into this world. Hope you enjoy this conversation. And if you know one person, just one person that you think would value this podcast, it would be a huge help to me and the team if you can share it with that person. Shahul, it is great to have you on here. I'm excited to talk to you, and I think we have to start with the big question, almost like the existential question. What does evaluation mean to you?
Yeah, so evaluation means to me is a way of really measuring and quantifying the performance of a system. So whatever it may be, it can be LLMs, it can be a traditional ML system or whatever. And why we should evaluate is because if we want to make any improvements on something, the first step is to measure and quantify it in the first place. Then only you will be able to do any kind of iterations on top of it and see if these iterations have made any positive or negative. What kind of impact has these iterations made in your system? So that's what is evaluation and why we should do evaluation.
Awesome. So basically, what you can't measure, you can't actually fix, and you got to iterate as much as possible to make it better.
Right.
And so when it comes to evaluation, I mean, you wrote an awesome blog post that I saw and I loved, and you talked about all the different ways that we can evaluate. And I think that it stood out to me. There was a few things that stood out to me. Probably the first one is that we have all these evaluation metrics, but it feels like sometimes when models come out, they just say how they do against these evaluation metrics. And just saying how they do against evaluation metrics, I'm almost like immune to that now, because it feels like every model that comes out says, oh, we're state of the art on these benchmarks or this or that. Have you felt that way too? And what do you think about that?
Right. Even as a guy who deals with these open LLMs on a daily basis for a variety of purpose, I have found it really hard to select an LLM for my own application or my own usage. And these open LLM leaderboards are actually going to be less reliable than more reliable, if any. And this can be because of maybe an ongoing competition or race to produce the best model in the leaderboard rather than producing the best useful model in general. So It's a tricky situation as of now. Everyone is trying to optimize for a particular leaderboard, and that optimization becomes a kind of overfitting to the particular data sets or leaderboard itself, and making the model or even the efforts less useful in the long run. So I share the same feelings, and it is something which the open source community and basically the LLM community has to figure out really quickly, so that people can actually choose an LLM and actually know which LLM is at least good for a particular task or something, and rather than just trusting random leaderboards which could be blindly overfitted to the leaderboard itself.
Yeah, and let's just double click on that for a moment, because why are these random leaderboards getting gamed? Is it because some of the evaluation test sets are being used in the training and then they're overfit for that? So it's like the model basically knows the answer before it's asked the question? Or are there other tricks that are happening?
So there are two reasons that I've mainly observed. The first one is the one that you pointed out. These data sets and tasks are all open. So people can use these data sets to fine-tune their model on these data sets itself, which means that model has which already seen that test set. It basically breaks the preliminary assumptions of formulating a test set. That test the model should not have seen the test set before. So that is the first problem. And the second problem can be the use of evaluation metrics that have poor correlation with human judgment. Even these days, many of these metrics that we use does not really have high correlation with human judgment when it comes to long form answering. So basically, when you say data sets or even evaluation, you will have different types of data sets. One data set could have a simple one word answer. It could be one word question answering, and some other data set could be something like long form question answering. So for short form question answering, it is basically very easy to compare. Okay, if you expect the answer as New York City and the model gives out something like New York City or NYC, you'd either figure out some metrics to see that okay, these answers were similar and hence the model was correct. So for long form answering, there are very few data sets available, and there are not really very good evaluation metrics available to do it. For example, how do we evaluate the capability of a model to write a summary or a long story? So then they introduce different dimensions. For example, coherence, fluency, etc., etc., and these dimensions are evaluated on the basis of mostly traditional metrics, which are not really highly correlated with human judgment. So that could be a reason why the evaluation metrics itself fails, or even the method itself fails. And the first one is obviously the overfitting to the test set, which should be avoided. So Kaggle has a very similar situation. Whenever they host a competition, they have to evaluate these models that people submit, right? So what Kaggle does is that, okay, the player should be able to understand or have an estimate of the performance of the model on leaderboard, but that estimate will not be final. So there will be a public test set and a private test set. So it ensures that the model are not overfit to the public test set. So if you have a 100 sample test set that you are trying to optimize for, you could train your model anyway and just optimize for that particular data set itself just by measuring the performance 10 times, right?
Yeah.
But that's not the ideal outcome. The ideal outcome is something which is much more generalizable. So that's why Kaggle keeps a private leaderboard and private test set to avoid any of these situations. So that's an effective thing that open source can adopt.
Yeah, it seems like we're missing the other side, which is the private test sets. And I guess right now what's happening is each person who is dealing with these models comes up with their own private evaluation metrics to go against. And it might just be something as simple as, does this work for my use case? How much do I have to prompt it, et cetera, et cetera. And you were saying how you're working with a bunch of open source LLMs right now. And it's really unclear. I know that every time I messed around with open source LLMs, what the hardest thing to do is recognize, okay, I have a use case, let's say summarization, like you were saying, which is a bit harder to evaluate. And now I just want to know which one of the open source models out there is the best at summarizing long text. You can't really get that information. It's super obscured. I wish there was a way to just say, all right, cool. If you're trying to do this use case, use this model at this given time. It's the best open source model that you've got.
Right. I mean, something like that would be really useful. There is an initiative called HELM from Stanford, and they're doing a good work, and I hope they continue it and improve the evaluation as in a better way. But evaluating all these LLMs itself is a task because it takes a lot of compute. So you have to run these LLMs on all these different data sets, and then take the output and have a evaluation metrics to quantify the results, all that stuff. So it's again compute intensive in a way. You have to have some kind of compute sponsorship to evaluate such stuff.
Yeah, and it's funny because it feels like it's almost like this paradox that as soon as an evaluation test set becomes public, then it's no longer useful. So for me, it's funny because I've heard a lot of people say that benchmarks are bullshit, and that basically when we talk about benchmarks, especially with LLMs, it shouldn't be used to gauge how well this model actually performs in the wild. And I know that you've undoubtedly had this, and I'm sure a lot of people that are listening have had this happen to them too, where you hear on Twitter or on LinkedIn, oh, there's this new model that dropped and it's been so good. It, does its state-of-the-art soda on all these different metrics, et cetera, et cetera. And then I go and ask it my favorite question to ask. It's like, is the Earth flat? And it says, yes, of course the Earth is flat because we have pictures of it. And you're like, whoa, this was trained on one too many subreddit threads.
Even if we say the current benchmarks are very limited, as we discussed. So even if we improve that slide of benchmarks, okay, let's say we have all these closed set, private set, test set and everything. If you want to really use an LLM extensively for a particular application, for a custom application, you better evaluate it yourself in your custom data distribution. Because it's not really practical to evaluate LLMs on all these stuff individually and present it somewhere. So benchmarks, even if it's done correctly, it will give you a ballpark idea of, what is the performance of this LLM on a particular task or particular data, all that's it. So it's a ballpark performance generally. I think that's the purpose of benchmarks. Not really say that, okay, it does not really guarantee a performance on any particular application or any particular data or anything. So if one is going to use any LLM, whether closed or open source LLM, and building an application on top of it, I think the person should figure out some evaluation metrics and have it evaluated whenever they make changes to the pipeline. Node itself, the LLM pipeline can have multiple other components that affect the LLM output other than the LLM itself. So whenever they change the part of pipelines, they should have evaluation metrics figured out so that internally, or they could subscribe to any of the SaaS solutions that are experts in evaluating LLMs, and evaluate the LLMs whenever they make the change so that they know that this is something they can push to production without worrying about it breaking or annoying customers.
And for you, what are some of the key, because you map out in your blog post a lot of different ways to evaluate LLMs. How are you recommending that we evaluate these? Like with which standards and which ways of evaluating? Because I imagine it's not all of them. If we could, and you do make this very clear, a little bit of a tangent, but in the blog post, you also say how expensive and time consuming it is to actually go through this process of evaluating. And so what would you recommend if we're just trying to figure out, like, what's the best way for us to evaluate it against our own data and our own use cases?
So the problem can be broken down into different steps. Okay, the first thing you have to figure out is in your application, what would be a reasonable test set that you have to evaluate. So the test set should contain the expected distribution of data which you are exposing the LLM to. For example, if you are building a retrieval augmented system and the people are always asking the system about summaries and stuff, you should have some kind of prompts and user prompts that have these kinds of distribution. Okay, what is the summary of this document? What is the summary of that? All that stuff. And then the next step should be to figure out the dimensions, the aspects that people really care about, or even you really care about. So when you get a summary, what are the aspects of summary that you really care about? Okay, so let's see if in my case, it could be fluency, coherency, and abstract. How much level of information from the actual content does the abstract capture? All these stuff. So let's say I have identified, now I have a test set. The second step, I have identified some aspects, some dimensions that I really care about or my users really care about. And then I have to figure out a method to quantify these aspects. So this can be done, quantifying the aspects can be either done using some string match, or you can use an LLM to evaluate the LLM itself. So I think the future of evaluation, even multimodal audio or LLMs itself is AI itself. So I think in future, AI will evaluate AI systems, but these evaluations will be formulated in such a way that it cancels or it is not really affected by the biases that are inherent to AI systems. I think in LLM's case, you could either use LLM itself to quantify these aspects, how fluent is the output, and how coherent is the output, etc., etc. So now you have to figure out a method to use LLM to quantify this output in a way that it is not really affected by the biases of LLMs. Some of the biases of LLMs, like LLMs usually only give integer scores, like some of the things which I pointed out in my blog.
Yeah, you also mentioned, right, there's one piece where you said LLMs prefer the output of other LLMs rather than human-generated content.
That's a funny thing, right? So if you want to, so this was I think probably one of the experiments. So there was some of the best golden annotated human answers, and then there was answer from some LLM or GPT 3.5 or something. And when evaluated, LLM mostly prefers answer from LLM itself because there is a bias to its style. So it's basically just subscribing to that style of answering. It's not really looking at any particular. So if you give two answers and ask LLM which is the best, you are not really asking the LLM to pinpoint to any aspect or something. You're just asking which is the best, and LLM mostly prefers a particular style of answering, like humans do. Okay, we also do have some kind of bias like that. So when it was also proved in some of the experiments, I think. So there are many leaderboards which allow humans to rate answers. So basically, then they show two answers from two different LLMs and ask which answer was the best. So what happens in that scenario is that the people who are judging the answers usually only care about the style of answering, which is not appropriate, right? We also want to take into account complex things like how was the factuality and other stuff. People usually only care, jump to conclusion by just looking at the state. I think LLM also suffers the same kind of bias, but in the case of LLMs, it just prefers its own style over the style of even human or any other LLM.
Yeah, it's almost looking at the answers and judging it not only on one metric, judging it on many different rubrics and saying, okay, well, writing itself, I like this one better, but the actual facts or the way that it's presented, the arguments, et cetera, the flow, you could see how it could get really out of hand quickly on how many different ways you can judge the output. And so again, going back to evaluating it, it's like, what are you evaluating it for? And what is the most important for you? And I think you brought up a great point. It all comes down to your use case and what you're going to be seeing in the wild. And so if you're mainly seeing summarization and you're mainly seeing that your end users like to get their summaries in quick bullet points type answers, then you should probably bias for those type of test set evaluation metrics.
Right.
So there is another thing that I wanted to mention, which is around once you see that you have proper evaluation metrics and the model is failing for some reason, or the output isn't that good, how do you debug that? What do? Do you make a better RAG? Do you fine-tune the prompts? Do you fine-tune the model? Do you get a different base model? It feels like there's so many X factors. And so where do you even start on that?
I think it comes down to first isolating the error itself and, figuring out, okay, which part and why it happens, and then solving for it accordingly. So there could be many reasons. If from the LLM viewpoint, there could be many reasons. From just LLM viewpoint, there could be many reasons why it fails. For example, if you see Llama 2, people are trying to, I think, fine-tune Llama 2 for code applications, but it is not going to get much better in code applications because Llama 2 was, by default, was not trained in much code tokens as required. So basically the percentage of code tokens it has seen in the pre-training itself is limiting its knowledge in code. Then you fine-tune, then doing fine-tuning on top of it only will, will improve the results, but it is also prone to overfitting. So I would isolate the error like this and then draw my conclusions and then figure out the next base.
So it's almost like you have to know a bit of, and this like Llama 2 not being good at coding is news to me, and I feel like I'm very deep in the subject, but it's almost like you have to constantly be checking, and I guess it's probably because I didn't read through the whole Llama 2 paper, and they may have said that. And so if you're not up to date on each one of these models and what the training data was that went into it, it can potentially drive you crazy because you're like, okay, let's just grab Llama 2. Everybody's saying it's the best out there. And let's see if we can fine tune it on our coding use case. And then little do you know that it's never going to be that good.
Right. So I think, I think the thing is that this is where, a guy who has good exposure to these things notice. So even if a person who is just trying out these models really won't notice these stuff, because that person it's like just trying out stuff. Okay, every model, okay, which is the best model? Everyone says that this is the best, so this should be the best. So, but you'll have to dig through stuff especially when it comes to open source LLMs and using it in production or using it in use cases. You'll have to really dig through it, understand, okay, what are the methods that they used, how different is this from any other LLMs, and so on and so forth, and then choose, then make a wise decision on which LLM to fine tune or use for your use case. I think in future it's going to be crazy because there are going to be many good foundational LLMs or foundational AI models. And then to just choose models from it is itself going to be a hard task.
We haven't even touched on the idea of the prompt injection or the security of the models, which feels like all of the evaluation metrics that I've seen, they don't really talk about that. Like, this model is able to get hacked 9 out of 10 times. Nobody's going to say that we were the most secure model or the least secure model, and things like I know there was a whole Reddit thread that came up around Dan or Do Anything Now,
Right.
and how there's that constant push and pull between making the model less useful because it won't tell you things since it thinks it is bad and it shouldn't say that. And then on the other side, making the model secure and not telling you things because it actually is bad, right? So I know there was a lot of tweets that were going around and memes when Llama 2 came out, and it said, how do I kill a Kubernetes cluster or something like that? How do I kill this? And Llama 2 is saying things like, no, I'm a language model. I'm not going to tell you how to kill anything. And so
it's funny, it's I really love the work the Llama 2 team did. Apart from the kind of alignment they did, I think they spent a lot of effort in alignment, but alignment itself is really, really hard. And to get a good reward, to produce a good reward model, to get the model aligned, that's a very, very hard task. I've worked in it for Open Assistant team, and there is it's like a very it's like a data problem. There is very few data which is available in open source that we can use to align language models. So it needs a particular type of feedback data. I think OpenAI has those feedback data because OpenAI has these user interactions and people's feedback from a long time, and then they can use these people's feedback itself to train language models. So Llama 2 was fairly over-aligned, and Llama 2 chat to specific, but Llama 2 does not have that problem, fortunately. So alignment, it's a very tricky problem, and the current alignment is looking at a way that, okay, it is currently aligned to, I think, subscribe to maybe a particular culture or something. Say, for example, alignment is subjective, right? So something which is offensive in where you belong to might not be offensive in place I belong to, right? So there are these cultural differences and all that stuff which is not currently taken into account in language model alignment. It is currently just aligned to a mainstream culture or whatever. So I think in future alignment would be something which can be even personalized. So that also could happen. Yeah.
So I'm thinking potentially you would get different alignment depending on where the companies are based or the end user is based, depending on the cultures that person is in. And so you're going to have all of these, maybe it's the same base model, but it has different alignment because of where it's being used.
Right, exactly. That's the idea. So I think alignment in future will be like that. It should be something which it should be aligned to a way that it serves the population in the best possible interest of humanity. And yeah, and it should be it should not be something which is just a mainstream culture. So it's just that a model is only subscribing to a mainstream culture, but the model can be aligned easily. It can be aligned to different cultures, but just that if you have n different aligned models to different cultures, it means that you have to deploy n different models. So it takes some kind of overhead in production, but if it's worth in future, I guess it will happen.
Yeah, it's those trade-offs. And speaking of trade-offs and putting things into production, coming back to the evaluation sets, you mentioned how costly it can be and how curating with ground truth is expensive, it's time consuming, and to maintain that golden annotated test set against data drift is a challenging task. Have you seen it done well, and what does that entail? Like, what should we expect to have to do if we wanted to do that? Because something that I find fascinating is people thinking that they can bring open source models in-house, and they don't realize all of this work that's going on with, like you said, with OpenAI or with Claude, behind the scenes, not only to host the model and to get the latency low, but also to make sure that it's continuously being evaluated and having these golden test sets come up.
So a test set, a golden test set should have some kind of annotated best answer to it. And that is mostly the hardest part to maintain, because whenever you update your test set, you'll have to have a set of people who can annotate the best answer to the given question or prompt, or best outcome to the given prompt, let's say. So how to overcome this situation is something which we have been exploring. So there are dimensions, or there are methods by which you could effectively evaluate LLMs without a golden annotated answer. Using LLM assisted evaluation and avoiding such biases from LLMs and identifying the right dimensions to evaluate and quantify can be a solution to it. And we have been using this pretty effectively in retrieval augmented generation systems.
Yeah. Hey everyone, my name is Aparna, founder of Arise, and the best way to stay up to date with MLOps is by subscribing to this podcast.
So basically in retrieval augmented generation systems, some of the aspects that we really care about is how grounded is the answer to the given context. So if you give a context, even if the model knows much more than the given context, the model should only limit itself to the given context. So how can we quantify it? How can we quantify hallucination? Do we need an annotated ground truth to quantify that hallucination? Or can we do it with using another LLM and forming a paradigm so that we can quantify it effectively? So I think in future, again, LLM AI will evaluate AI systems, and the part which I see, which is very difficult to evaluate without an annotated ground truth, is factuality or factuality of the answer. Factuality, it is a widely debated topic, and we can even relate to that with fake news detection. It's an age-old problem, and it's very, very hard to solve problem, and nobody has solved it yet. So the thing is that, what is factual and what is not factual, and what is acceptable, what is not acceptable, all these things are really complicated, and that except that dimension, which is really complicated and which is also an age-old problem. I think there are many dimensions which we can evaluate without having much human effort by using LLMs itself to evaluate LLM generated output.
So let's talk a minute about OpenAssist and what you've been doing over there and how you've been overcoming some of these challenges with evaluation. Has it been through the, what I've heard it called, so RLHF has gotten very popular in the last 6 months, but I also have heard it called RLAIF. So it's reinforcement learning through AI feedback instead of human feedback. Have you been messing around with any of that too? And this is really what we've been talking about, right? Like getting the evaluation through the models, other AI models, and they will tell you if it's good or bad.
Right. So it's the basic idea of, again, aligning AI models with AI itself. I believe strongly that this is going to be the future. And if you see, even for fine tuning, test set curation by human annotation is very expensive. So before we used to have, say for example, if you want to build an NER, named entity recognition system, you basically will have 1,000 documents, and then you have to upload these 1,000 documents into Amazon Mechanical Turk, and then 100 people somewhere in the world will annotate each entities in each document for you. Now you don't really have to do it. You can actually do the same thing with maybe 1/100th of the cost, and using LLMs itself, and even much, much faster. So I think in future, AI will generate the data that it needs to be trained, maybe with human supervision, some weak supervision, and AI will evaluate and align AI systems itself. Again, all these should happen with at least some weak human supervision. But I think the human in the loop, the number of humans in the loop will be reduced to, very, very small percentage.
And as far as Open Assist goes, what have you been up to on there?
So in Open Assistant, I have been doing variety of stuff. I used to work in reward modeling and alignment team, where we work on aligning our fine-tuned large LLMs and release it. Now I have been involved in. I have been very interested in data set. So for fine-tuning, I think after playing with fine-tuning all these past 6 months, what I've really understood is that data is the king in fine-tuning. So if you know to prepare the right data for fine-tuning with the right model, you'll get the best outcome. Just throwing some random data to model and fine-tuning, it's not really difficult, to be honest. To fine-tuning a model, maybe because I have been doing it for a while, but it's not really difficult to throw some random data and fine-tune a model.
Sorry, I was going to say, at the end of the day, what it seems like is it's not useful if you just throw some random data at it.
Yes. So basically, if you want to do that, sure, you're free to do that, and it's not really difficult. What is difficult is to produce a high quality model. And how to produce a high quality model, it's basically garbage in, garbage out. So if you have a high quality data, and if you have figured out methods by which you can produce high quality data to fine tune LLMs, that's where the value is. And that's where I have been mostly working around these days, because we have the fine tuning set up for even 70 billion Llama 2 model. And we are currently doing fine tuning for 70 billion Llama model. And mostly in there, whenever I find some spare time, I spend on data preparation and filtering and all those techniques. So that's something which I've been really contributing to Open Assistant, and we are planning to release a 70 billion Llama 2 model this week.
Nice. So by the time this is out, then everyone will have probably heard about it, and we'll leave a link in the description. And now I want to contrast that. So basically, you've been doing fine tuning with Open Assist, but then you also have Ragas, which are a way to evaluate RAGs, or the retrieval augmented generation, which I think most people are playing with much more than fine tuning. Now, in your mind, since you play in both realms, the fine tuning and the RAGs realm, and just a quick side note, I love the name Ragas because is there in India, there's Ragas, right? The singing are Ragas, the different scales.
Right. So Ragas, actually we named it like RAG, Retrieval Augmented Generation Assessment, and it came out to be Ragas. So it's a cool name and it's easy to pronounce. So we thought, okay, why not?
Yeah.
So, yeah.
But there is in singing, right? Is there not Ragas?
Yes, in singing.
That's awesome. All right, so back on track. No. When it comes to fine-tuning versus RAGs, you've been playing in both fields. I've gotten the impression that you don't want to fine-tune unless you absolutely have to. You want to try and see how far the RAGs can get you.
Right. So this is again some topic which I have been meaning to write on. So the way I look at it, as I agree to your point, like you should not fine tune until and unless it is absolutely necessary. But I think fine tuning and retrieval augmented generation serves two different purposes. So the thing is that fine tuning is not really meant to inject any factual information to the model. So if you have a model, let's say even GPT-3, let's say whatever model, like Llama 2 or something, it is trained on all these tokens and all stuff, but you are going to use Llama 2 on a private data set that resides on your enterprise. Fine-tuning doesn't really make sense in that situation, because by fine-tuning, you cannot really inject new factual information to the model. If you do that, that's called overfitting. Why do we fine-tune? Fine-tuning actually enables, instruction fine-tuning actually enables model to think in certain way. Let's put it that way, think in certain way given certain instructions. So even though the model has internal knowledge about things, it really do not really understand the way to think, or understand the instructions correctly and output the answer correctly. So fine-tuning will enable you to do it. For example, let's say if you have a model which you have pre-trained on only data which is in low domain. Okay, let's say we have this model, and this model has only seen the data which is in low domain during pre-training. Most of its knowledge is now confined to the low domain. You cannot really take that model and fine tune on something like life sciences and expect it to perform good. Why? Because fine tune does not really help model to absorb that kind of information, factual information. It helps model to think in certain way. For example, let's say you want model to follow and call a particular function when someone says something. Let's say I have a function. Opening functions is a good example of fine tuning actually. So they have this model, they have this base model, and whenever the user says something which could trigger a function, they wanted the model to do it. They wanted the model to think in certain way. For example, okay, what is the weather in Boston? And I have a function which I also give a function which can get the weather given the location. So in this case, the model gets two things. Basically, a function which has an argument called place, and I'm also conversing with the model and asking what is the weather in Boston. So in that case, I want a model to think in a way and output function of Boston. So that's a good example of fine-tuning. In that case, model had the predefined knowledge of what is a function and how does the function look and what is the code and all that stuff. But we just nudged the model in a way that it was able to think and follow the instruction properly. And this fine-tuning can improve the benchmarks and performance of the model, because as we have seen, the model itself followed the instructions in a much better way. So when it comes to RAG, you cannot really do this. Okay, you cannot really inject any information to the model using fine-tuning. You have to do, even you have the capability to fine-tune models. The places where you have to use retrieval augmented generation, you'll have to still continue doing that, and that is something which works nicely and effectively. So these are independent things, and I think there is, I think I've been meaning to write on it, and there is a popular confusion, okay, that fine-tuning is an alternative to RAG, or RAG is an alternative to fine-tuning, but I don't look at it that way, and I don't think it's that way.
They're complementary in a way, is what I'm understanding you saying. And
yes,
just because you have one doesn't mean you are going to not have the other. You still can fine-tune and use RAGs 100%.
Yes, you can fine-tune and use RAGs. Yep.
I guess what I'm wondering is, what have you seen be a valuable use case besides this OpenAI functions use case that you're talking about for an open source model and a company that wants to fine-tune an open source model? Why would they do that? What are some use cases there? Like, what's going to make me think, okay, now I need to just go and fine tune this?
Okay, so interesting question. So let's say you have to, you are basically running a company. I'm just saying my own example. So in my case, I want to build a model that can evaluate LLMs itself. So in that case, I want the model to output things like, okay, why, if this answer can be actually attributed to the given context, and why that happened, all that stuff. So I want the model to think in a particular way. So the output should look like, okay, this is the sentence one, this is the first statement of the generated answer, and this statement can be attributed to this part of the context. Then it goes and on. So basically, the model is learning to think and answer in a particular way. So whenever you have those kind of application where, okay, you have a base LLM, or you even have an LLM which is already fine-tuned, but you want the capability of, you want to improve the capability in a certain aspect or certain aspects, you could prepare the data in that particular way and use fine-tuning to improve the model performance in that certain aspects. But that won't really just to reinforce is that part should not really be injecting new factual information to the model. So if the let's say if I have a model which does not really know who is Socrates, there is no point in asking or fine tuning the model with all the things that Socrates has said or whatever, because model really does not really understand who is Socrates in the first place, because it has never seen it has never really understood that this guy has existed or whatever, all that stuff. That happens in the pre-training stage. So that is the difference, yeah.
In that case, it's funny because I think a lot of people, including myself, with the image generation models and like the diffusion models, you think about fine-tuning in a different way, which I always thought about fine-tuning with like diffusion models as, okay, I'm going to add me, Demetrios, to this model now so that I can call and say, Demetrios meditating on a rock on the sun, and then I would get a picture of myself and it was image generated. In the LLMs, it's a much different story though, because it's you telling it, no matter how many Demetrios notes you fine tune an LLM on, it's not really going to pick up that, okay, Demetrios talks like this. For that use case, it's better to use some kind of a RAG and just say, here, some few shot learning, and say, here, use it, speak like Demetrios. Demetrios speaks like this. Here's a few context items, and then you get the output in that way. What you're talking about with the fine tuning is that you want to give it almost like a new way of looking at the world, or a new tool in its tool belt, to be able to ask it, hey, can you do XYZ, which it before it couldn't have done, and now you have this new way that it can say, all right, yeah, now I understand what you mean when you say XYZ, which is like almost like a different job or a different I am trying not to use the word function because it goes back to the OpenAI one, but it feels like it's a different way of executing. Am I getting that right? And where am I wrong there?
Right. I think what your perception is right there. Maybe I'll add just more one example. Say that you have a model that have already understood coding in Python in pre-training stage. So basically it knows all these, it has in its internal parameters all these correlation, all that stuff. We don't really know what the model knows in its internal parameters. We don't really know what the model learns, right? So what let's say let's go with the best assumption that model has learned many things, like, okay, what is the relationship between all these stuff, all these words, all that stuff. But that doesn't make the model follow instructions in a way. So let's say I'm coming in the next day and saying, okay, I'm just redesigning Python and I want to use semicolon at the end of every statement. And write me a Python program to do X, Y, to do this with all these stuff. So even though the model has an understanding about Python and all that stuff, model is not able to understand how to think in a way, how to think correctly, and how to think correctly so that it serves your instruction the best way possible. So that capability is what fine-tuning brings, and all that internal knowledge about coding and stuff, all that internal knowledge about Python variables, relations, and all that stuff, that's learned during pre-training stage. So initially, we also nobody really knew that, okay, fine-tuning is, this is what fine-tuning does. This is what I have seen happening, and this is our best possible, research that, this is the best possible thing that research has given us right now, and this is why we use fine-tuning why we should use fine-tuning with our current knowledge.
Awesome, dude. Well, our time is coming to an end. For anyone that is looking to evaluate their RAGs more deeply, I would highly encourage you to check out Ragas. As we mentioned in the episode, it is awesome. It's some really cool work that you're doing with that. And for anyone that wants to connect with you, where's the best place to find you?
I am active on Twitter, so you could connect me on Twitter. And with Ragas, our aim is to improve the reliability of LLM applications, either with evaluating, testing, guardrailing, all that. So if you have any if any of you hearing me has any application, let me know, and I'm always open to chat.
Excellent. Well, thank you, Shahul. This has been wonderful, man. You taught me so much. I appreciate it. We'll end it there.
Hey, I'm Vishnu. I'm a data scientist at Firsthand, and I definitely think that you should subscribe to the MLOps Coffee Sessions podcast. It's the best podcast out there to stay on top of what MLOps actually is, to talk to the true thought leaders in the space. And oh, by the way, Demetrios is absolutely hilarious. What a weird guy. You should definitely subscribe to the podcast.